On Thursday, at the end of class, we're talking about symmetry. A function which has mirrored symmetry about the y-axis is called an even function. So that means here's the y-axis. Does the left mirror the right? And this one does, so it's even. This one is odd. A function which has rotational symmetry about the origin is called an odd function. That means if you put your pencil right here on the origin or your pen and you turn it upside down, the graph will look exactly like it does now. So I'm going to turn it 180 degrees and it looks the same now as it did when I started. So that makes it an odd function. That's how you can tell with a graph. So now, to test the function for symmetry requires, like if they don't give us the function, okay, they give us, I'm sorry, they don't give us the graph, they give us the function. So again, we have even functions and we have odd functions. So what we're going to do is, and you're going to have to prove it. So you take a negative x and you plug it in for x. Okay, remember anything in this parentheses that says x is equal to a negative x. So wherever I see an x, I'm going to plug in a negative x. If it ends up to be the exact same that we began than what we had to begin with, then it's an even function. If all, not just two or three, all symbols or all signs switch, then it's odd. And if only some of them switch, it's neither. Okay, so let's talk about this one right here. So what I'm going to do is I'm going to take the x out and I'm going to replace it with a negative x. So I have 8 minus, and I'm going to take the x out and I'm going to replace it with a negative x to the fourth power. Okay, well, this is going to give us a positive x to the fourth because we have 4 negative signs. So now I bring down my 8 and I bring down my minus sign. So that tells me, comparing this to this, they're the exact same. Okay, so that means it's even. That means f of x, which is this function here, is equal to the function, the f of negative x. Those two are equal. So that tells you that it's even. Okay, let's do the same thing here. We're going to take out that x and we're going to replace it with negative x. So that means 6 to the negative, or 6 times negative x to the third minus 2 times negative x. This part right here gives me negative. Okay, 3 negatives, 3 is odd, so my answer is negative. So that gives me a negative times a positive, so this beginning one is going to give us negative 6x to the third. I just moved that negative to the front. Right here, I have a negative 2 times a negative x. If you want to change your signs, you can. I don't, okay? I just leave it as a negative x. I'm sorry, negative 2. But you can change the sign. Negative times a negative gives me a positive 2x. So at this point, I'm comparing that to that, the original. This changed, so it can't be an even. This changed, but this one, oh, this one did as well. I was getting ready to say this one didn't. They both went to the opposite. This was positive, it became negative. This was negative, it became positive. All signs changed. So that tells you that this is how you write it. In fact, this one's going to be g of negative x is equal to the opposite of g of x, basically, is what that's saying. You don't really have to know this part. It's just what this is saying. This is odd. The way that I learned it is if it looks the exact same, it's even. If it looks the exact opposite, it's odd. This one right here, I'm going to take out the x and put in a negative x. I'm going to have 6 times negative x to the third minus 2 times negative x plus 4. Okay, this gives me a negative x to the third times that 6 is going to give me negative 6x to the third. Negative times a negative gives us a positive 2x plus 4. Now, on this one here, it's different. These change, this one changes, but notice this stays the same. So not all signs change, so this one's neither. Okay, again, even has to be the same. Odd, they all change. If only some of them change, then it's neither. Okay, for the function, determine the following. Okay, we're going to talk about the domain. First of all, domain are all x values that we use. Well, -1, -2, -3, -4, -5. Okay, so we're going to do it in interval notation. Our graph starts at -5. It is an open circle, so we're going to use parentheses. And then from there on out, we use every x value because see how this continues? So it goes towards a positive infinity. We always use parentheses with infinity. Range are our y values. We are going to read now for domain, you read your graph left to right. For range, you go from bottom to top. Well, that arrow keeps going down, so it is going towards negative infinity. The highest point is this one right here. That is this is 1, 2, 3, 4, 5, and 6. So our highest point is 6, and there you don't see a hole like you do here. It is included then. Even though you don't see a dot, it's still a dot. I could put one there, but it's included, so it's a bracket. It's a bad bracket. Okay. And I'm going to do this. I don't really know why I labeled the y-axis, but it's okay. It's no big deal. Okay, our intercepts. We have two different types of intercepts. We have x-intercepts and we have y-intercepts. Let's do our x-intercepts first. It touches the x-axis at -2, so that is -2, 0. And this one down here is at 6, 0. I'm writing mine as ordered pairs. Alex might, I think it switches back and forth. So if I ask you for the x-intercept, you could just tell me -2 and 6. If the directions say write it as an ordered pair, then this is the way we want it. Then the y-intercept. In Alex, that's where it crosses the y-axis. It crosses at 4. So in Alex, it might just accept 4. But if it asks for an ordered pair, you're going to put 0, 4. Make sure the zeros are in the right place. Okay. If it's an x-intercept, you have to have numbers in the x position. If it's a y-intercept, you have to have a number in that y. When I say numbers, it can be 0. It could cross through here. But like this 4 has to be in that y position. We talked about this on Thursday. That is telling you x is equal to 5. But they don't give us something to plug it into. They don't give us the function. They give us the graph. Well, this is saying when x is 5, what is my y? Okay? I need to know what my y is because that's my x. So this is what I always kind of do. Because sometimes they're going to give us this and we have to find our x. All right, so we're going to go down to 5 and it goes up 1, 2. There is the point 5, 2. So our answer is 2. It's not an ordered pair, okay? It is just the number 2. Increasing intervals. We're not doing decreasing, just increasing. Okay, so it increases. I don't know if this pen here will work. Okay, so we're going to start from the left. Our graph goes down. It gets to -2, and then it starts going up. Nope, it's not going to work. So it starts climbing until it gets to this point here. Now the hard part to remember here is it's x values only on increasing and decreasing. X values only. So it is between this -2 and this +2. And I talked about this the other day on Thursday. It cannot increase and decrease at the same time. So that's why we use parentheses. Always parentheses on increasing and decreasing. Okay. Piecewise functions. These are not hard. Just pretend like it's just two formulas. And it all depends on which of these formulas you use, depends on your domain. I use domain because we're talking about x values. If my x value is less than or equal to 0, we're going to use this one. If it's greater than if it's greater than 0, we use this one. Don't make it hard. But for the domain of this whole piecewise function, it's every single number on the number line. So it is going to be -infinity to infinity. We're always going to write it in interval notation. Okay, this is telling me that x is equal to -6. So you first have to find where -6 falls in our domain, and it falls right here. It's less than 0. So we're going to plug -6 into that function. We're going to say 2 times -6 plus 5. -12 plus 5, and we get -7. Right here, this is telling us that x is equal to 0. So what you're going to do is you're going to go up here in the domain and say which one does it fit. Does it fit here in the bottom or the top? Because this is equal to it, it fits in the top, so we're going to use that one again. 2 times 0 plus 5. 2 times 0 is 0 plus 5 gives us 5. And now f of 2. Again, this is what my x is equal to, which is 2. So we're going to, again, go into our domain first. We're going to look at that first. It's greater than 0, so we're going to use the bottom function now. So I'm going to take out the x and plug in a 2. And 2 minus 3 gives me -1. Shouldn't be too hard. Okay. All right. I was just looking at my notes to see if there was anything I needed to tell you. No. Okay. By generating more points, you can sketch its graph. It is always handy to divide the graph at the x value, which splits its domain. The 0 is what splits the domain. Okay. So we're going to have the right side of the graph, and we're going to have the left side. Now, this one is not the best graph in the world, so I'm going to try my best. Go -6 and down 7. I don't know if I'm going to be able to do it, but I'll try. 1, 2. Close enough. I'm going to try to make it as best I can. I wish we'd have had graph paper. 1, 2, 3, 4, 5, 6, and 7. Okay. So the reason I chose this to go 6 and -7 is because this here, that's a point -6, 7. -6, comma -7. I said 7, but so I would go left 6. 1, 2, 3, 4, 5, 6, down 7. 1, 2, 3, 4, 5, 6, 7. Yeah, I had it. Just making sure I don't have lines, so it's kind of hard. I'm going to put a point right there. We are going to use a 0 because that's the point that divides these two graphs. At 0, it was 5. So let's go up to 5. And it's equal on this one, okay? It's equal there. So I'm going to have a solid dot. Now, I don't know if I have anything to draw a line with handy. Use this notepad, the back of it. Okay, so it stops at 0, but it continues to go down past that point. We just graphed 2 points on that line. Now, I could graph more points if I wanted to make this line, you know, have more points. It's probably not the best, well, because I don't have graph paper. Hopefully it's pretty accurate. So, and this here, the reason I got 0.5 is that's the point 0.5. Now, this point right here, this is the point to -1. Now, that point is this one right here. Okay, so let's go to -1. Right here, okay? But I'm still going to graph 0. Where would, if I plugged in 0 here, it would give me -3. Okay, so there is one down here, but instead of a closed circle, I'm going to make it an open circle. Okay, so that means at 0 it's going to be counted up here, but not down here. But then I can draw my line. And it continues to go. I could put more points. I could pick, let's say 5. I could put 5 in here and it would be 2. 5 minus 3 gives me 2. So if I had gone further, it probably would have been about right in here. Okay. So that's what the piecewise function looks like. And not all piecewise functions look like this. They all are different. Sometimes they might have 3 lines instead of just, or 3 equations instead of just 2. So, okay, difference quotient. I will do this in class, but you need this for your next math class. In my class, we learn to solve it. We don't learn why we need to learn it. Okay, in your algebra, your next calculus, business calc, they'll teach you when you're going to use it. Me, I'm just going to teach you how to use formula. Now, here's the thing. I'll tell you where people mess up. Okay, first of all, it says this expression you'll use in Calculus 1 to create what's known as a derivative for a function, f of x. Here and now, you only need to be able to simplify the expression. Okay, I'm going to tell you right now, this is the hardest part. And it's not even that hard. I don't understand why people have trouble, but here's what we're going to do. This will be given to you on your test. That is not something that you have to have memorized, even though it's a pretty easy formula. Okay. And we're going to take this in 3 steps. We're going to first do this f of x plus h. Then we're going to subtract the original function from it. You don't have to do any work for the f of x. It's already given to you. Then you get your simplified answer there, and then you divide it by h. But the hardest part is the very first step, which is finding f of x plus h. Now, I already told you this is your x. Just because it's x plus h doesn't change what you do. So here's what I'm going to do. Wherever I see an x up here, I'm going to replace it with x plus h. So I have 3 times x plus h minus 5 times x plus h plus 7. I just left some room so I could change my color pens. Okay? Nothing hard. Nothing difficult at all. Here's where it shouldn't be difficult, but that's where people will mess up. Now, it's not hard. I was going to do this on a separate sheet, but I can do it over here. I talked about this rule before in class. If you know the rule already, which I do, you square the first term, you multiply these two and get xh and then double it. You have two of them, so it'll be 2xh, and then square the last term. Okay? Now, let's say you don't know that rule. Well, bring this over here. And you're going to tell me what that means. When you square something, you take what you have and multiply it by itself. That's what you're doing when you square something. There is no shortcut to give you x squared plus h squared. That's not it. Because what's going to happen is, if you go to do this over here and you use FOIL, you're going to get x squared. X times h is xh. H times x is xh. And h times h is h squared. X squared. Look how many of these you have. You have two of them. So it's 2xh plus h squared. That's what I do. Because see, I know the shortcut to it. The shortcut to get this middle term right here is to multiply these and then multiply them by 2. X times h times 2. That's what I got here. Now, I'm going to bring this down. Minus 5. Oops. Minus 5 times the quantity of x plus h. And you could have distributed already. That's fine. I'm just going to do it in the next step, because I have to distribute this. Now again, I haven't done anything hard. The hardest part was doing the FOIL over here. 3 times x squared is 3x squared. 3 times 2xh is 6xh. And 3 times h is 3h. Negative 5 times x is negative 5x. Negative 5 times h is negative 5h plus 7. Okay? Nothing difficult. Okay? It gets a little long, but it's not hard. Okay? So here's what we're going to do now. Now, what I'm going to do is I'm going to take this. Now, I usually don't do this if I'm working it by myself. I just then subtract this from it. Okay? But I'm going to rewrite this all down here. So what I did was, in that step 1, I just found that answer. It's going to be that big long one. So what I'm going to do is I'm going to take the f of x plus h, and I'm going to subtract my f of x from it. Now this is just rewriting it, which again, if I was working this on my own, I would not do this part. I would just continue up here. So I'm just going to copy that down here. Now I am going to take this and I am going to subtract my f of x, which is right here. That is what's given to us. Again, I haven't done any work. I'm now doing this whole top part. I'm getting that whole answer to the top. Now, I don't feel like writing that all over again. So I'm just going to distribute this negative. I'll rewrite it. I don't want to, but oh well. I guess I should because I'm teaching it. Okay, so now when I distribute this, that 3x squared becomes a negative 3x squared. Negative times a negative gives us a positive 5x. And negative times a positive 7 gives us a negative 7. Anything that follows a subtraction sign changes signs. That became positive. I'm sorry, that became negative. That became positive. That became negative. Now, you'll notice we're going to simplify. Those two things cancel out. The positive 5x and the negative 5x. The negative 7 and the positive 7. And we're left with 6xh plus 3h minus 5h. So something really long became really short. That's the answer to that whole top. The last step is to divide by h. You should be able to get it to cancel out. Okay, so I'm going to take my answer from step 2, okay, oops. Why did I not? Oh, crap. See, you're not here to tell me. I didn't square that there. I was like, this shouldn't be happening here. It didn't really I mean, it just kind of, I just got to add it all in. So that was an x squared. See, I tried my shortcut and I missed it, but I had it over here. I just didn't write it. Okay. Same thing here. This is going to be h squared. So this is an h squared. Sorry. See what happens when I'm doing videos? You're not here to help me. Don't worry about putting this in any type of order. Don't rearrange, just write it the way it is. Okay? You will notice I'll never rearrange it. Okay, so that was my answer from step 2. Now that it's correct, I'm going to divide by h. Now, I just cancel an h in all the top. These h's will cancel. I'm left with 6x. One of the h's will cancel here, so I have plus 3h. And these h's will cancel, so I'm left with minus 5, and that's my answer. Okay. The other way you could have done it is you could have factored out an h in the top. And got this all over h. And then my h's cancel, and I'm still left with 6x plus 3h minus 5. And I think that is done. This problem here will definitely be on your test. Okay? You will have one. I'll just change this function. It's the same steps though.